Hey, Emily.
Hey, Siobhan, what's up?
Is your refrigerator running?
I think so.
Well, you'd better go catch it. Dang, this is one cool fridge.
They're my cookies! Did you guys know the frozen Thin Mints are like 10 times better?
Huh, I've never had them frozen.
I can't believe we're doing refrigerators for our physics project.
While refrigerators are pretty important, they keep your cookies cool.
So, how does a refrigerator work?
Well, let's find out.
Refrigerators. Today we take them for granted, but they make our lives so much better. With the help of refrigerators, we are able to preserve our food on a scale that was never possible before. Before refrigerators were invented, food would have to be salted or buried underground in order to preserve it for longer periods of time. The basic concept behind refrigerators is cold refrigerant gas is pumped into the refrigerator. As it absorbs the heat exerted by the objects are kept cool. And here's a fun fact, refrigerators were invented in 1805 by Oliver Evans.
The compressor constricts the refrigerant, raising its pressure and pushes it into the coils on the outside of the refrigerator. When the hot gas in the coils meets the cooler air temperature of the kitchen, it becomes a liquid. Now in liquid form at high pressure, the refrigerant cools down as it flows into the coils inside the refrigerator. The refrigerant absorbs the heat inside the fridge, cooling down the air. Lastly, the refrigerant evaporates into a gas, then flows back into the compressor, where the cycle starts over.
This is the equation for the coefficient of performance of the refrigerator. The K represents the coefficient of performance, the Q sub C is the heat exerted, and the W is the work needed.
Okay, this is the formula for Newton's law of cooling. So this says that temperature at a certain time equals the temperature of the surroundings plus the temperature at the start minus the temperature of surroundings times e to the negative k, which is a cooling constant, times the time.
The coefficient of performance is used to find out how efficient the refrigerator is. This problem is finding the coefficient of performance of a refrigerator that exerts 30 joules of heat while doing 15 joules of work. Q sub C is the amount of heat pulled out of the refrigerator, while W is the work needed. Since 30 joules of heat are pulled out over 15 joules of work done, the coefficient is 2.
Okay, let's see Newton's law of cooling in action. A bowl of pasta that is 200 Kelvin is put into a refrigerator that is 20 Kelvin. After 180 seconds, what is the change in temperature that occurs if the cooling constant of the refrigerator is 0.00 Hertz? In this equation, T sub S is the surrounding temperature, which is 20 Kelvin. The temperature to start with is 200 Kelvin, which is the temperature of the bowl of pasta. Using our equation, we discover that the change in temperature is 102.6 Kelvin.
Well, that was fun.
I guess we shouldn't take our refrigerators for granted.